Hi guys, welcome to the 2020 AIME 2 video solution. Let's start. First problem is asking, find a number of positive integers that satisfies m squared n is equal to 2020. It's equal to 20 to the 20th power, right? So, first I want to prime factorize this thing, okay? So, we can know that 20 to the 20 is basically equal to 2 to the 40 times 5 to the 20. So, but then we know that m squared, m has a constraint because m has a constraint, right? You can't just put any number in there. M must below 20. M must below 2 to the 20 or 5 to 20, 2 to the 20 or 5 to the 10, right? Which means that there will be, since m have to be below 20, so which means there's 2 to the 0 to 20 and 5 to the 0 from 0 to 10. These exponents will all work in m, and they are multipliable. So, which means there will be 21 for 2, and there will be 11 for 5, which means there will be 231 positive order pair. Let's start with the second problem. So, second problem is saying let P be a randomly chosen point at a random in the interior of the unit square. So it's basically just a unit square with origin as one of its vertices, and the probability that the slope of a line determined by P and the point 5 over a comma 3 over a is greater than or equal to 1/2 computed times m over n, where m and n are relatively prime positive integers. Find m over n. Let's erase everything. Let's erase everything here, okay? To give more space. So for this problem, we can see that the thing that we have to do is we want to draw a graph. And we want to label the axis. Let's say something like here. Right? Label the graph. And then we can just find the region that fits all the conditions. Right? So this is 1, 1. And each of this represents 1/8, implements of 1/8. Right? And the line and the position that's given is 5 over 8 comma 3 over 8, which is here. And let's enclose this area to make it clear. So we want to find that what is the possible what is the region that the points can possibly lie in, that the point and this point will have a slope of greater than 1/2. So first we want to see that we want to eliminate all regions that will cause us negative slopes, which is entirely this whole region. Because if you get somewhere like here or somewhere here, then it's gonna be a negative slope, which is definitely gonna be less, right? So we don't want to consider this. We don't want to consider this part of the region because this will always result in 0 or negative slope, right? So now, what are we gonna do with these two of them? So we want to set up an equation. The slope that the point and this 5 over 8 comma 3 over 8 is gonna be determined by this, right? So we want to first find that what is the smallest. So given if x is 0, then what is gonna be y? Then will result in, if this is 5 over 8, then in order for this to be 1/2, you have to have 16 over 1, right? So we know that the y-intercept is gonna be 116. somewhere here, right? And we see that next one, if x is not 0, let's say if x is 1/8, okay? If x is 1/8, then we want to have this gonna result in 2/8. So y is also gonna be equal to 1/8 in this case. So let's graph this. We realize that we just want to find this line that where the region crosses, right? And we want to check that if this is gonna meet that line. So let's start. So basically we see that 2 points, one of it is 0, 16, and another one, let me erase this thing. So we realize that one of the point, so we want to determine the slope that's made by these two lines. So one of it is 0, 16 over 1, and another one is 1/8, 1/8. We use the slope formula, we get 1/8 over 1/16, which is equal to 1/2, right? So we realize that if we plug in x over 2, let's say we just plug in 0, then we want to add 16 over 1 over 16, which this is equal to y. So the only thing we have to do is we have to check if this is gonna work. If you plug in 5 over 8, are you gonna get at 3/8 in this case, right? Which, if we plug in 5 over 8, then we will get 5 over 16 plus 1 over 16, which is 6 over 16, which is 3 over 8. So this works, right? I want to draw a line here. That's going to meet here. So we want to find this point, and we just want to determine, and then these two triangles are not going to result this in 1/2. So we just want to, so we already know that these two squares both have, one of it has area of 25 over 64. Another one has area of 3/8 times 3/8, which is 9 over 34. So we just only want to find these two, the region of these two triangles, right? These two triangles over here. So we plug in this and we see that this is 1, right? So 1 over 2, which is equal to 8 over 16. So this is 9 over 16, right? And we know that the height is 3 over 8 because we know that this is 3/8. So we want to find this. 9 over 16, we subtract 9 over 16 by 3 over 8, which result in us in 3 over 16. 3 over 16. So this is 3 over 16, and this is 3 over 8, and we times 1/2, which we get 9. So this area is equal to 9 over 256. And this is basically just similar triangle. We get, and we basically just multiply this by 25 over 9 because of similar triangle, right? So then we'll get, cancel out, we'll get 25. So which means that this is equal to 25 over 256. So we just want to add all the areas, right? We want to add all the areas of the success. So we want to find this area and we subtract these regions. And then we can get our area of succeed. Area of success. Okay, let's start. We already know that the area is 1 because it's a square. 1 minus, so parentheses 25 over 64 plus 9 over 64 plus 25 over 256 plus 9 over 256. Multiply each by 4, we get 136 plus 34 over 256, which will result us in 86 over 256, which is equal to 43 over 128, right? And then we add this, we'll get 171, which is our solution. Let's continue with next one. I can't erase it. So let's start with problem number 3. It says log base 2x to the 3 to the 20 is equal to log base 2x 2 to the x plus 3, 3 to the 2020, right? This is actually 2 to the x power, okay? So if we know the basic of logarithmic, then we know that if these are proportional, then these are proportional, right? If the exponent of the base, both of them have the same base but the different exponent and they're proportional, then these must have the same ratio between these two. So we can just set up an equation, right? X plus 3 over x is equal to 101 because 2020 divided by 20 is equal to 101, right? So we get 101x is equal to x plus 3. We get 100x is equal to 3, and x is equal to 3 over 100. And since they want n plus n, which is 103, and this is our solution. Thank you for watching. Have a great day and see you next time.